You can type it into the chat box, and Mr. Bates will answer all questions at the end of the webinar. I am Mary Ressler, and I'm the Councils and Components Specialist for IFMA. And thank you again for joining us to this webinar today, brought to us by the Corporate Facilities Council. And now I will turn it over to you, Paul.
Great. Thank you, Mary. Appreciate your patience today with us while we work out our technology issues. You know, the computer is a wonderful thing, but it's really interesting how it will do things that you wouldn't believe. Oops. I'm sorry, Mary. I need to get this speaker piece off. There we go. All right. So consequently, this particular presentation is called Healthy Indoor Air Quality by Design. And what we're going to do today is, given that we have an audience of facility managers, we're going to talk about the importance of indoor air quality as it relates to the built environment. If you will, go ahead and switch to the next slide, please. What we're doing is stepping through some of the accreditations. So if you'll go ahead and move through these, I'll just tell you when to stop. We'll start here with the learning objectives. You know, today we really want to understand the huge impact that air quality has on human health. You know, we're very concerned about energy efficiency and water usage and decreased waste consumption. But a lot of times we don't consider what's going on with indoor air quality. And so we'll talk about why that's important today. We'll also talk about how to identify the various types of indoor air quality pollutants that are out there. We'll help you understand the difference between VOC content and VOC emissions. And we'll lead you to a resource where you can find these healthier products that are in fact low emitting. On the next slide, you'll see the title, and then we'll keep moving through these. Mary, please. This course is accredited by the AIA, and on the next slide, you'll see that it's also accredited by the IDCEC for people who are interior designers. And on the next slide, you'll see that it's also accredited by the U.S. Green Building Council, GBCI, for 1 hour of continuing education maintenance. This course is reported under the improvements to the indoor environment category, low emitting materials. We'll move on to the next one. Well, as we start out our discussion today, what we know is that indoor air quality, actually, believe it or not, there is an official definition of what acceptable indoor air quality is. And ASHRAE, which is the American Society for Heating, Refrigeration, and Air Conditioning Engineers, has given us a definition which is really quite interesting. It says there, air in which there are no known contaminants at harmful concentrations as determined by cognizant authorities and with which a substantial majority, which is 80%, do not express dissatisfaction. So this is a really prime example of the 80-20 rule at play. Well, when you think about it, there are over 300 million people in the United States alone. 20% would be 60 million. Is it okay that 60 million people do not have acceptable air quality? We would hope that you would think that the answer to that is no. If we move to the next slide, please. So in talking about air quality today, we want to talk about the importance of not only content, but also emissions, and how that plays a really big part in enhancing the quality of the air that we breathe. And as we move on to a discussion about who you can trust, what you will find is that all of this information has been put together in a very concise place, and that resource is available to you online. On our next slide, what we know is that there are a lot of different things that make up a particular air sample. For example, we see things like VOCs, which are volatile organic compounds that are typically made up of carbon-type atoms that come together to become radical. An example of this is formaldehyde, other aldehydes, things that we commonly use in printers and toners like benzene, toluene, but also a number of the chemicals that we find in cleaning products also are classified as volatile organic compounds. Anything in the aldehyde family is an example of that. Well, we also find things like inorganic and organic particles. So we mean dust, dander, pollen, allergens, bacteria, mold, and then of course there are things that come in from the outside like inorganic and combustion gases. So that means things like carbon dioxide, carbon monoxide, and then of course the things that come in from the combustion engines and vehicles that are in the outdoor environment. So you put all that together and what you have is chemicals that can come into the interior space and get trapped if they're not properly ventilated to the outside. And quite honestly, from a proactive standpoint, if you're putting furniture, finishes, equipment, paint, building materials into the building that have these chemicals in it, you're creating an even more hazardous environment. On the next slide, what we'll see is that a lot of people still don't really believe that this is a major issue. So we entered into a study with the Centers for Disease Control, and over a 10-year period, we studied about 2,500 different participants of varying ages, and what we found was that 50% of them, in their sampling of the blood in their bodies, cancer and hormone-disrupting pesticides were detected in more than 50% of those people. In addition, flame and fire retardant chemicals were found in nearly everyone that was sampled. And that you see down there at the bottom, BPA, which is bisphenol A, it's a plasticizer that we've used. A lot of times you find it in bottles, plastic water bottles and other types of plastic used in our country. Was found in 90% of the people sampled. Females had higher levels than men, and children had the highest levels of all. So what this is telling us is that there are a lot of chemicals that are building up in our bodies that, quite honestly, we may not even be aware of until they create a reaction. And we're beginning to see this health impact in our society with people who have things like multiple chemical sensitivities. We're seeing people who have developed diseases that we really don't understand completely, like MS. How about autism and autism spectral disorders as an example? And then, of course, one of the biggest ones is asthma and allergies. Well, on the next slide, what we see is that a lot of times the symptoms related to indoor air quality are both chronic and acute. And if you'll press the enter button, Mary, there's a little bit of animation on this slide. You know, if this is what you look like on a Friday afternoon, probably means that you did a lot of really good work that week and you're ready for the weekend. If this is what you look like on Monday afternoon, then there may be an air quality problem in your building. And so the symptoms that you see shown here are both, as I mentioned, chronic and acute. The way you know that they're related to air quality, however, is that they tend to come and go when you're in that particular space. Many people who are affected by air quality issues will tell you that they immediately have a reaction when they're in an environment that is not favorable. Once they leave, the symptoms tend to go away within an hour. So you can see some of them are not as harmful as others, but you can imagine chronic nosebleeds, chronic dizziness and nausea could very much impact the productivity and the quality of work that you're providing in that particular space. Well, on the next slide, what we also know is that this asthma and allergy issue has been the reason that air quality has become such a huge topic. Asthma in children has increased 160% just in the last 10 years. What we also know is that in the United States, people miss work, they suffer asthma attacks, visit the emergency room. But probably the most shocking information that we found out about asthma is that now we're finding people in their 30s, 40s, and 50s developing asthma who did not have it as a child. And that's typically not the normal progression of the disease. Typically people develop asthma early on, about 50% of them outgrow it, the rest of them deal with it through medication. So this is especially an important fact given how many janitorial and housekeeping workers that we have in the United States, roughly 4 million, and the rates of asthma and cancer as a result of exposure to these chemicals, it's been clearly documented. And so we've got to do something different about the chemicals that we're using in the indoor environment. Well, on the next slide, what we're going to see here is that just the amount of the volume, if you will, of contaminants in a space can be really alarming. What we know is that indoor pollution is 2 to 5 times higher than outside. And given that people spend between 85 and 90% of their time indoors, and given the fact that a lot of times these chemicals are not ventilated out properly because we've decreased the ventilation rate in the buildings because we're trying to be more energy efficient, we've created a real problem. In a newly constructed space, indoor air quality issues can be as much as 1,000 times higher than in an existing space. And so consequently, this creates a real issue for us because we've been conditioned by our marketing folks to believe that that new paint, that new carpet, new car smell is a good thing, when in fact it's actually very harmful because what you're smelling are chemicals. When you smell something, that typically means that there are chemicals coming off of it that are potentially harmful for you. Well, as we move to the next slide, what we are trying to present here is that there have been 2 major reasons why air quality has been brought to everyone's attention: the health impact and the financial impact. Unfortunately, it's the financial impact that has really caused businesses to stand up and take notice. So let's talk about that first. Just huge losses related to indoor air quality. Just a couple of them listed here. $63 billion a year in lost productivity and increased healthcare costs related to air quality problems. A third of commercial U.S. buildings don't have acceptable indoor air quality, affecting 55 million workers. And interestingly enough, the #1 reason why tenants leave a space or building is because, not because the rent went up, it's because of HVAC issues or perceived air quality issues. You know, it's really interesting with air quality. People have varying degrees of sensitivity to smells and odors. And so when one person smells something, they'll look over at someone else and go, "Hey, do you smell that?" And that person says, "Well, I don't really smell it." Then given that enough of the people in the space may smell it, everyone else tends to believe that they now do smell it, and so consequently you have a perceived odor or chemical problem that quite honestly may not be a real issue, but because someone who is very sensitive to smells picked up on it, you've now got a problem. So all that to say that there is clear and compelling evidence and data to support the fact that there are big money losses from indoor air quality problems. Well, on our next slide, what we know as well is that a lot of this has happened because we've changed the way that we build our buildings. You know, if you look there on the left of the screen, we've moved from natural, very primitive building materials to much more sophisticated, but unfortunately chemically charged building materials that we're finding out now are off-gassing and creating problems for us. Well, and this building on the right is a really great example of what we typically see in the United States and developing countries today. A multi-story building composed mostly of glass sitting on an asphalt parking lot with no green space around it. So here's the problem. If we build the building too tight, it doesn't breathe. When it doesn't respond to its environment, which is what we're getting ready to talk about now, it presents another set of issues. So in this building, when you've got lots of glass curtain wall on a building, that is presenting a real challenge for the HVAC system. On a daily basis, the HVAC is trying to decide, is it a cloudy day? Is it a sunny day? Is it a cold day? Is it a windy day? Is it warm? Then the HVAC has to work differently on each of those days. So that creates a real challenge for keeping the air quality optimized. Well, then, of course, the fact that there's no green space around the building means that there's nothing to filter the air that is being brought into the building. And of course, sunlight interacts with asphalt to create ground level ozone, which is actually harmful for you to breathe. The ozone levels that are recorded on asphalt parking lots, quite honestly, are very, very high. And so one of the reasons why a lot of times if people spend a lot of time on an asphalt parking lot, say you go to the fair or to a carnival or something like that on a sunny day, people actually report feeling lightheaded, feeling shortness of breath. The result of that is that the reason for that is that the ozone levels are impacting their health. Well, the other issue that you can't really tell from this picture on the right is that the intake for the ventilation for the whole building was located near the loading dock where trucks would sit and idle all day, bringing materials in and out of the building. That simply allowed combustion gases to come into the space. So given that we have compacted workspaces inside and these issues we've just mentioned, you can see where the fact that the building materials have added another layer of problem to a problem that existed already to create now a more hazardous indoor environment. Well, on the next slide, what we want to talk about is the fact that there are known issues that unfortunately high-performance building programs out there do not address. And during the course of the presentation, I am going to talk a lot about the LEED program because it is the rating program of choice used in North America. But I'm not picking on them. I'm just simply showing you that while that's a really good start, it doesn't necessarily address all of the health issues that we're here to talk about today. So for example, small particles, pesticides, flame retardants, plasticizers, all these issues have known health problems, but yet they're really not addressed by any of the rating systems in a meaningful way. And so we've got to move beyond what the rating system says, and so a big reason why we're having this presentation today is to talk about the health impacts. So let's move on to the next slide. And what we know is that a big part of the problems that we're having today is because 95% of materials that manufacturers use, they can list as proprietary in nature, and that means they don't have to disclose it to the general public. Well, that's not ever going to work, is it? Because we need disclosure in order to understand what is in the products that I'm buying. Well, what we also know, if you'll move on to the next slide, is that a lot of these chemicals, we tried to do something about them back in 1976 when the Toxic Substances Control Act was enacted by Congress. But unfortunately, it's done a very poor job of actually monitoring what all is out there. As an example, only 5 of the 20,000 chemicals that have been introduced since 1976 have actually even been banned by the EPA. And believe it or not, there are actually 80,000 known chemicals today. And so if only 5 of them have been banned, you know, we're falling woefully short of knowing enough health information about these chemicals to proceed with caution. So consequently, we've got a real challenge on our hands because manufacturers need to be better at disclosing what is in their products, and one of the ways that they can do that is through having their products certified and evaluated by organizations who are qualified to do so. Well, on the next slide, what we're going to see as well is that even in a room that looks as benign as this one, you see lots of neutral colors and flat surfaces, not a lot of frills. Unfortunately, even in a space that looks like this, there can be serious chemical issues coming from the various furniture, finishes, and equipment and the care of them. So moving on to the next slide, what we want to do is we want to step you through a discussion about why content and emissions are so important and yet so different. You know, when we talk about content of VOCs, what we mean is whatever is in the wet product. So what you see here illustrated is paint. Paint is a really great example of wet content issues. A lot of the paint that's out there on the market today is listed as low VOC content. Well, what we know is that there's also another part of VOC problems, which is VOC emissions. So what we wanted to do was show people that just because something is low VOC content does not mean that it will also be low VOC emitting. So we took 26 paint samples from all the major paint manufacturers that had a low VOC stated content on their label, and we tested them using the environmental testing chambers, which is what the EPA and other testing agencies use. And what we found is that 9 of those 26 samples failed to meet the emissions requirements. So that's about 35% of the samples didn't make it. And what we found is that 7 of the samples had formaldehyde emissions that were above the California chronic risk exposure level for emissions, and 2 of the samples had a very prominent chemical known as ethylene glycol emitting from them that, quite honestly, affects very sensitive environments. And so what we can say is that just because something is low VOC content doesn't mean that it's also low VOC emitting, and here's why. Paint in the can, or any other wet product for that matter, in the can with the lid on will never hurt you. But you take that paint out and apply it to a wall or other substrate. As it dries and cures, it's physically changing properties. It's going from being a liquid to being dried as a solid. And when it does that molecularly, that allows it to emit chemicals at levels that are higher than when it was in the liquid form. So the other real impact in this is that, especially for these facility managers, what it can do is it can cause a real problem for the TVOC, or total VOC levels, in your building. So here's an example. People who are building a high-performance building, say, will go out and decide, you know what, we're going to use this low VOC paint. But unfortunately, it's only low VOC content paint. Well, then they finish building the building, putting the furniture in. They go to do the test of the air quality in the building before they move people in, and find out that they failed, and they're confused. They're like, why did that happen? We thought we used all low VOC paint. What happened was you used low VOC content products and not necessarily low VOC emitting products. So there's a huge difference. I can't tell you how many times this has happened to a building before they're finished. They do the indoor air quality testing and fail because they didn't understand the importance of content versus emissions. So a very, very important point. As we move on to the next slide, I just want you to be able to understand why content and emissions are such an important piece. Well, we wanted to step through each of the different products that could be used in an interior space and just talk about the potential issues with them. So there is animation on this screen. Mary, if you'll click, it should bring up the flooring component, which you see there. You know, with flooring, we have lots of options. And depending on the type of environment that you guys are working with, you may choose resilient flooring like hardwood flooring. You may choose carpeting. You may choose VCT, vinyl tile. You could choose a rubber flooring, for example. These are just some of the ones that are available, and each of them have challenges. So, for example, with hardwood flooring, we know that wood inherently contains urea formaldehyde. But in addition, we know that the chemicals that go on top of it, for example, the stains and colorants that go into it to give it its particular color, the polyurethane coating that goes on top of it to make it more protective, and then the cleaning chemicals that we have to use to clean that particular type of floor may add additional chemicals into the mix that we did not intend to be there. Same thing with carpet. Carpet padding, carpet backing, carpet adhesives, all of these have known chemical issues. Then there's things like VCT. You know, especially for vinyl tile that's used in a lot of educational commercial spaces, we equate a shiny floor with a clean floor. But what went on to that floor and what went into the labor on that floor to give it that shine? It had to be stripped and waxed and buffed. And so all of that is adding more chemicals to the mix. So rubber flooring, like resilient flooring that you would find from a quality rubber flooring manufacturer, I'm not talking about recycled tires, but the quality rubber flooring that's available commercially, is a lot of times a better answer if that works for your application. A lot of times it can be cleaned just with water. It's ergonomically safer as well. So just some considerations there regarding flooring. As we move on to the next item, what we're going to see is that we're talking about wall construction. You know, with wall construction, a lot of times there can be issues with the wall board, like gypsum, which may have levels of urea formaldehyde in it. In addition, what goes on top of the wall? We talked about paint. How about wall coverings? Here, wall coverings, especially the use of vinyl wall coverings, we see many times items that contain PVC, which, you know, PVC is a chemical that unfortunately releases dioxin when it's incinerated, which is a carcinogen. There's also plasticizers that we find in a lot of the vinyl wall coverings, like BPA, and one known as phthalates. Phthalates are a chemical that we inject into plastics to make them softer. And so you can imagine vinyl wall coverings, plastic arms on chairs, plastic coatings, all may contain these chemicals. And phthalates have actually been shown to cause male reproductive issues, so much so that in the state of California, they've actually banned the use of phthalates in products that are used by children 3 and under. And they're looking to expand that ban in California that all products may not contain certain levels of phthalates. Well, let's move on. On our next item, we're talking about, in many cases, casework. Again, we're talking about wood casework that may have issues with urea formaldehyde. A lot of times we're seeing plastic-coated wire shelving being used in light commercial, industrial, and residential use. And so consequently, what we know is that they've got this issue again with plasticizers. Then, of course, there are the paint and stains that sometimes go on the casework that is wood. So, again, we're talking about those issues. On our next pop-up, we're talking about, a lot of times, equipment. In a more residential space, you could be talking about the flat screen TV or VCR or DVD player. And so what we know is that anytime you add heat to a plastic element, you're simply accelerating the emissions off of that particular product, which is one of the reasons why the printing processes tend to go hand in hand with this particular problem. We know that benzene, toluene, other chemicals of concern come off of the printing processes and can be released into the indoor environment. So for those of you that have built a high-performance building according to the LEED rating programs, you know that LEED recommends that those types of processes be isolated and that room be vented directly to the outside to prevent those kind of problems and exposure of chemicals. Well, on the next pop-up, what we're going to talk about is furniture. And with furniture, we've talked about, you know, the fact that a furniture item has multiple components. It can have a wooden component, a fabric, a metal, and a plastic. Well, we've talked about some of those particular components. Let's talk about the metal component. You know, with some wooden item or furniture items, we see a lot of chrome being used. Chromium is a heavy metal. It's just like lead, mercury, and arsenic. It actually can be absorbed through the skin, and in addition to inhalation. And so stainless steel would be the better particular product to use because it is not porous and does not leach chemicals into the environment or onto our skin. Well, the other issue is with textiles, which we'll talk about in just a second. But as we continue to move on, the next pop-up should be about paint. We've talked about the issues with paint. Make sure you're using a low-emitting paint and not just a low VOC content paint, because there really is a big difference when it comes to health. Well, the last pop-up is textiles. And we talk about textiles because, quite honestly, it's usually not the fiber that's the problem. It's what's on top of it. We put stain repellent, fire retardant, antimicrobial properties on top of fabrics, we think to make them more serviceable, But unfortunately, what we find is that they're a lot of times just adding chemicals to the mix which are not healthy for us. And I would like to, as an aside, talk a little bit about flame retardant and antimicrobial properties. There's a lot of information out there about the need for products to be fire safe, but also knowing that the chemicals that we're using in fire retardant products quite honestly create a health issue for us. So you have to very carefully weigh, and I understand that a lot of this is driven by codes and standards, but make sure you know exactly what is being used on those particular products and whether or not they truly require a flame retardant application. Quite honestly, in this country, we flame retard everything that goes into interior space because we feel that it's better that it not burn. And so the same thing applies with antimicrobials. Antimicrobial properties have been largely pitched by manufacturers as making the product safer. But what the health community has very clearly stated, there is not any clear and compelling evidence that antimicrobials prevent the spread of disease in any meaningful way, and simply just add more chemicals on top of the fiber, which again may create issues for human health. So again, proceed with caution. Read the information and make sure you know what you're dealing with before you agree to accept a product that has those types of applications. Well, so we put it all together as we move on to show you that by clicking forward, Mary, what we'll see is that we've got a lot of different chemicals coming into the space from different sources that quite honestly create this hazardous environment. So when you're creating a space, understand that all of these have different issues, but they come together to create an environment which quite honestly is potentially harmful to the occupants in that space. On the next slide, I wanted to begin to mention some of the standards that are out there that try to address air quality, but unfortunately fall short. There's one in particular which you'll see written throughout the LEED programs and others. It's called California Section 1350. It is a standard. It is not a certification. A standard simply means you must do this, 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 and it'll meet the standard. Whereas a certification says, we have verified that this particular item does not meet these chemical levels and does not emit or contain harmful chemicals and therefore is certified to be safe. So this California Section 1350 standard, which was actually created a number of years ago, only covers 35 chemicals of concern. And when we know that there are 13,000 that can emit from any given product, and there are potentially 80,000 out there, 35 certainly falls very short. So as we move forward, what we want you to see is that, on the next slide, is that we've got to do a better job than what the rating systems tell us. And here's why. When we talked about that content versus emissions situation, I wanted you to see that in one particular rating program, we've got a disconnect, and we're emphasizing the wrong thing. So as an example, if you look down the left side, we've taken the low-emitting materials credit as shown. Across the top in orange, you see 4 of the LEED rating programs. Buildings under construction, which is formerly known as new construction for healthcare, new construction for schools, and commercial interiors. Look at how many of those credits have a green box showing that to get that particular credit, you have to meet a content requirement. Well, what did we say was the name of this particular credit, EQ credit 4? It's low-emitting materials. Why would you have a content requirement for an emissions criteria? Doesn't make any sense, does it? So, but look which one program gets it when it comes to the importance of emissions. You see the B, D, and C schools column? We know very clearly the impact that chemicals have on children's health. 85% of the brain's development actually occurs outside the mother's womb after birth. And so, given that primarily a lot of that happens before the age of 5, the chemicals that we're exposing children to in preschools, daycares, and the first year of school can be very, very critical to their actual development. Because what we also know is that the chemicals that we're exposed to at the earliest stages of our lives can have a huge impact on the brain. So we've got some work to do when it comes to educating people about the importance of emissions and not just content. Well, on the next slide, what we're going to talk about next is that there are ways to do this proactively, and it begins with an indoor air quality management plan. And so we're going to talk about how, at the very beginning, when we go to build a space or we do any kind of renovation, we start out and say that, you know what, indoor air quality is going to be a priority, and this is how we're going to do it. We're going to decide in the design phase, in the construction phase, and in the operations and maintenance phase that air quality is going to receive a lot of attention. So let's step through that, proactively addressing that. On the next slide, let's talk about what we do in the design phase. You know, here is where we need to get the designers and the architects and the facility managers and the janitorial staff and the GCs all together and say, this is our plan for a healthy environment. So in the design phase, we want to build a building that responds to the area in which it's built. So remember back to that building that had all glass and sitting on an asphalt parking lot with no green space? This is where we take care of that problem. We don't do those things. You know, we decide, are we going to use any kind of passive ventilation? Are we building this environment in an area where the HVAC is going to have to run all the time, all year long, or not? How are we going to lay out the space? You know, I'm sure there are a number of facility managers here who do healthcare and schools as an example. When you're building a school, typically the cafeteria area should be isolated from the rest of the school because of all the cooking and cleaning processes that are constantly going on. You definitely wouldn't want the air to be recirculated through the classrooms that's coming out of the science laboratories where they're dealing with chemicals, from the art laboratories where they're baking things in the art kilns and things like that. Same thing applies to healthcare. When people move into the emergency room, you definitely don't want that air to be shared throughout the intensive care unit, the surgical unit, the neonatal care unit. So programming, how you actually lay out the space, and ventilation, how you decide how to zone it so that it is ventilated properly and adequately, is key. Well, in the design phase, this is also where we decide from the very beginning we're going to specify the low-emitting materials. I will tell you that if you build a high-performance building and don't specify low-emitting materials, it will tell on you when you go to do the indoor air quality test before you move people in. It's that important. So don't skip that part of the process. Well, on our next slide, what we want to do is make you aware of the fact that there are other guidelines out there. Besides LEED, there are the ones like the International Green Construction Code, also known as IGCC, which created in March of this year, and it sets an international baseline for all buildings built according to that rating program. It has received a lot of great publicity. In addition, there's ASHRAE's 189.1, which was created kind of as a, if you will, LEED light type of program. You know, all buildings have as their goal, or I should say many of the buildings built today have as their goal to be a high-performance building. And so that's what 189.1 does. It is a code that is built to begin that process. And so it's the first step toward maybe achieving a high-performance rating program like LEED or other. Well, then there's Collaborative for High-Performance Schools. There's National Association of Home Builders. California has their own particular program. All of these deal with different environments. Healthcare has Practice Green Health's Green Guide. There are just a lot of different resources out there for you to look for high-performance guidelines. On our next slide, what we will also be able to tell you is that there are ways to make sure this happens effectively in the construction process. So once we've designed it, consulted whatever guideline we want to use, Now we get to build it. And for those who are involved in the A&D process, meaning architecture and design, this is a real challenge because in the construction process, you've got to rely on that general contractor and those subs to do it right. So for example, installing wet products like paints, adhesives, caulk, sealants, those kind of things. First, allowing them to dry and cure, and then installing absorptive products like ceiling tiles and carpeting is the more beneficial way to build a high-performance space. VOCs can actually come off of wet products as they're drying and sink into porous products, and then allow, as the building is heated and cooled, that allows those chemicals to continuously be re-released over and over again during the heating, cooling process of the building. So we don't want that to happen. Well, we want to protect our ventilation system. You know, it doesn't make any sense to use the permanent ventilation system during construction where the gypsum particles, drywall, dust, and other building products can be sucked into the ventilation system to then be blown out onto the occupants once the building is occupied. So using a temporary ventilation system is the best way to take care of that problem. Well, we know that weather events are going to happen and plumbing issues are going to arise. We want to make sure that during the construction phase, we have someone who is going around and vigilant about any moisture issues. You can imagine with moisture, there's a potential for mold and mildew. And given that about 90 to 95% of buildings will experience a mold and moisture problem in their lifetime, it can be very costly. And those of you that have ever been involved in any kind of mold remediation, you know that it can create huge issues for the employees and for the building maintenance team and facility managers. So encourage good housekeeping. You know, when it comes to the workers, we see them sitting on stacks of drywall, eating and drinking. We see discarded food items, food wrappers, soda cans. It's simply going to draw insects and bugs, undesirable elements to the construction site, which could have the potential to impact the indoor environment and those materials. And after the building is built, this is where we want to do our air quality test that I mentioned earlier. Better to know what issues you're facing before you move people into the building than after. We live in a very litigious society, and people are very, all too willing to seek legal action if they feel that something in some of their rights have been impugned in some way. So do the test, find out before. It will save you a lot of heartache later on. Well, as we move to the next slide, what we can also tell you is that the way to do that, there's a right way and a wrong way to do that flush out or air quality test. What we recommend is that because the flush out is usually more expensive, we recommend doing an indoor air quality test. It typically takes about 4 hours to do the test. The results can be released to you within 5 days. You can use that as documentation for your high-performance paperwork. If you don't, and you go through the flush-out process, flushing out 14,000 cubic feet per square foot of floor area of fresh outdoor air can take weeks. And nobody wants to delay the move-in or occupancy of a space because now we have to do the flush-out. So again, it goes back to specifying those low-emitting materials, doing the IAQ test, you'll pass and not have to deal with the flush-out process. As we move to the next slide, what we can also tell you is that there are things that we can do in the operations and maintenance phase, which with the facility managers present today, we may have greater interest in this particular phase. Because when you think about it, this is the phase that lasts the longest. You know, most buildings have a 40 to 70-year life expectancy, and so we know that things are eventually going to break down. They're going to have to be replaced or refurbished. If you're moving into one of those spaces that's a greener space or high-performance building, do you know how to replace those green products? Do you know where to go to find them? Do you know what kind of cleaning products to use to clean them? So establishing a high-performance cleaning program makes a lot of sense. And this needs to have buy-in from the top, meaning either the building owner or whoever is in control of that particular space. Make sure they understand that high-performance cleaning is essential to maintaining a high-performance building. You can put low-emitting products in, you can have it built properly, but then if somebody comes in at the end of the day and cleans with solutions that are full of chemicals, you've simply negated all the hard work that has gone on before. So educating people on the actual how to use the cleaning products, meaning application. As an example, we use a lot of aerosol products today. You know, when you spray an aerosol product, you're simply creating thousands of tiny droplets that can now be dispersed through the air. Better application would be to apply a wet product directly to a rag and then use that to wipe down the surface. So as an example, Wind-to-Clean. We see a lot of times in healthcare environments, school environments, that the cleaning, the mopping, and stuff like that is all done after the children have left the school or in the evening after visiting hours are over, so that it doesn't spread the contamination through the space when there are a lot of people moving throughout that particular space. And ultimately, we want to perform IAQ testing at a minimum once a year to find out, are we bringing additional chemicals in? We know that buildings are living spaces, if you will. We bring in chemicals on our bodies every day, plus the cleaning products that we use may have additional chemicals. And so we need to check periodically to make sure that we haven't tipped the scale unfavorably. Well, as we move on to the next slide, what we also know is that there are a lot of green products out there. And as we move on to the next slide, what we also know is that a lot of the products are not, in the past, have not been considered as durable. And so what we want to tell you about that is that there are a lot of green products that you should be very cautious about, because is it a truly green certified product, or is it simply making some green claim that's not verifiable? So as we move on to this particular slide here, what we're going to do is we're going to show you in a case study that there are right ways and wrong ways to do this. So as we move to the next slide, what we did in this case study was there were two buildings built at the same time, one of which was built in the state of Washington, and it was built in the LEED for New Construction program. Indoor air quality was a priority for them, and they did some of those things that we talked about. They installed their products wet before dry. They used a temporary ventilation system. They specified low-emitting materials, and they did an indoor air quality test before they moved people into the building. As we move to the next slide, what you're going to see is the results from that particular building's air sampling. So when you're looking at this particular graphic, I want you to look there on the left of the chart, and you see that funny-looking UG/M cube. That's micrograms per cubic meter. That's how you measure emissions of chemicals coming off of products. We're used to seeing grams per liter, or G/L. That's content of chemicals. Micrograms per cubic meter is emissions of chemicals. So the requirement was that it meet a 200, and we're looking at the green bar, which is the total of all VOCs in that particular building. 200 was the requirement. Week number 1, when they measured, now remember, this is the building that did everything right. Slightly higher, but by week number 2 had fallen below the criteria level. And then 3 months out was now below half. So very quickly reached a safe level. Now, I know there are people who are probably thinking, well, if they did everything they were supposed to do, why was it higher in week number 1? Well, a lot of times this is due to the fact that punch list items are still being completed. They're still commissioning and tweaking the HVAC system to get it just right for everybody. But the fact that it was only 50 micrograms per cubic meter higher, that is actually a very, very small number when you think about it in the grand scheme of things. And the fact that it reached a safe level within 2 weeks, very, very good. To move on to the next slide, what we're going to see is that the other building, which was built in Atlanta, same time, same square footage, they did not prioritize air quality. It was a new building, but it was simply built to code, not a high-performance building guideline. So let's look at the numbers for the air sampling taken from that building on the next slide. Now remember, this is still the same criteria, but look at the levels that were registered. 16 times higher in week 1, 14 times higher in week 2, and still 3 times higher 3 months out. So what a huge difference, right? So when you think about it, controlling emissions of VOCs makes a lot of sense. Well, as we move on to the next slide, what we can see is that there are a proliferation of green labels out there. And what A&D and architecture and design and facility managers have told us is that the product must first be durable. But after that, it must also be low VOC emitting. These are the characteristics that they desire for any particular product. So we know that you guys understand the importance of emissions. We just have to do a better job of actually implementing those low VOC emitting products going forward. Well, on the next slide, what you'll see is that there are commonly specified green products. Lighting is one of them, flooring is another, furniture is one of the others, and of course there's paint. So those are some of the big four that you see out there being used a lot, and a lot of those have issues with chemical and VOC content and emissions. On our next slide, what I'd like to do is, talk with you about what is available today that can help you find better products. And so it starts with the product level. So you see listed here product categories that actually have standards written to help you find a better product. So National Science Foundation, Underwriters Laboratories Environment. You can see there's a UL Environment 100, which is written specifically for gypsum wallboard type products. You can actually take these standards, insert them into the documents, and use them, or you as a facility manager can use these standards to understand what is included in those particular products. We move on to the next slide. We also know that the LEAD program has given us some very valuable information about how to find and what to specify for these greener products. 50% of the points in the low emitting materials section have to do with indoor air quality, have to do with low emitting materials. So let's talk about that for just a second. Go to the next slide, please. And what you'll see is that the easiest credits usually are the ones that we attain, and the ones that are harder, we typically leave those behind. So as an example, with this particular slide, you can see, look at adhesives and sealants. What I did was I took 66 different LEAD programs and I compared them. And what I found was that where the compliance requirement was a content-based requirement, those were easier to find, easier to achieve. Where there was an emissions requirement, those were harder to find, harder to achieve, so consequently they got left behind. So with adhesives and sealants, only 10% of those 66 did not achieve that credit. But look down at the bottom. Furniture and furnishings. 55% of those 66 projects did not achieve the furniture and furnishings credit because emissions was the requirement. Harder to find, more costly a lot of times for the manufacturers, and so consequently we tend to leave that behind. On the next slide, we actually begin to show you the, I believe it's in the LEAD rating program, the low emitting material credit and the compliance tabs that you can use to find those particular credits. So when you're looking to replace the flooring that's in your space, or when you're involved in some sort of new construction or refurbishment, look here to find the types of products that you should be looking for. So for example, with paints and coatings, look for a product that has a green seal or a green guard certification method on it. Same thing applies with flooring, furniture, with products that are surfacing materials, as an example, those also would use a particular certification. On the next slide, what we know is that one of the issues that's really being discussed today very hotly in sustainable circles is the importance of carbon offset, carbon footprint, And I will tell you that, at the end of the day, that really is not something that you can largely control. But health aspects, and your particular health in general, is something that you can control. And so indoor air quality needs to be a priority and not just an afterthought, if you will, when it comes to creating a healthier space. On the next slide, we want you to know that there are places that you can go to find guidance. So if you're looking for these healthier products, you can look on the Pharos Project, which is an online resource. There is the Green Spec and Green Format guides, which are located online. In addition to some of the others that you see listed here, there are a lot of different places that you can find guidance. But probably the most important one that we can point you to is some of the online resources available through Underwriters Laboratories Environment and the Green Guard website for low-emitting materials. So let's move on to the next slide. And these are the resources here. When you look at that second one, that is the one that you can find all the different products that you can potentially use during your facility management efforts. So very easy to use. It's free. There are more than 150,000 products located on that particular website. There are certificates there which you can use to prove compliance with the various high-performance programs that are out there. Some of the other websites listed there you probably recognize as being beneficial resources. I believe that that may be nearly the end of the presentation. Let's see on the next slide. Yes. So with UL Environment, and Green Guard, there are logos and marks that you can look for to tell you whether or not that particular product is in fact a certified, validated product, and how it is greener. Look for certified marks to find truly healthier products. Well, that concludes it for me. I'd like to open it up for questions if you guys have any. Be glad to answer those.
If y'all have any questions, y'all can type them into the chat box.
Well, I would like to say while we're waiting, if anyone needs to contact me, I'd be glad to take your questions. You can reach me at paul.bates@ul.com. I see a question there that just popped up from someone about the red list. Red list was a list that was created, quite honestly, by Google, trying to make the world a better place, but unfortunately the real truth is that it's been a huge failure. It was so prohibitive that no one can meet the requirements. And so what's happening is that a lot of organizations are saying it's a great ambition, let's try to eliminate these particular chemicals, but compliance with the red list doesn't honestly exist. So a lot of times you'll see people put red list items as things that they do not want to see in any product specified. But that's kind of the story behind the red list. I see another one there that says, do indoor plants have IAQ issues? Usually it's not the plant that's the problem, it's the soil medium and the fertilizers that we use in it, that as the building is heated and cooled and air blows over them, they can create chemicals in the indoor space. It's true that live plants indoors do take in carbon dioxide and release oxygen, but I will tell you they do not clean in any really meaningful way. And so if you think having a lot of green plants in the interior space is making it healthier, I will tell you it does not. The presentation will be available through IFMA, I believe.
Yes, I'll send out the presentation and put it in a PDF form, and then we'll also have the presentation recording.
Yeah. Somebody just flashed a question about furniture, or excuse me, about flooring and rubber and latex issues in healthcare. The flooring, rubber flooring products that are being used in commercial healthcare environments do not have the latex issues that you find in latex gloves and things like that. So I would encourage you to check some of the resources that are out there, because they do meet the requirements for people who have latex sensitivity. There are no agencies that regulate both emissions and content, because there is no regulation, period, on VOC chemicals. And quite honestly, there's debate out there. A lot of people feel that we don't want Big Brother regulating this particular industry, but at the same time, we know that something has to be done because manufacturers are not going to do it themselves. So we've got some problems there. You know, the perception is that if the government gets involved, there may be real issues with quality, and so that's why it's kind of been kept out. I see some messages flashing up, but unfortunately they're going a little bit too fast for me to read. I believe I missed one of them, at least one of them.
One was, let's see, was there, what can be used to wipe down furniture with an antimicrobial cleaner that will not damage the furniture?
Unfortunately, there's not a lot out there, which is why we've got a real problem, because a lot of the products that are out there are trying to kill bacteria, and yet they're simply adding chemicals to the mix. So if you have a product that has an antimicrobial finish and you're trying to wipe it down, you're going to need to contact the furniture manufacturer to find out exactly what they recommend cleaning with. Because typically, products that have an antimicrobial application, you simply wipe them down with water or a lint-free rag. We see a lot of microfiber rags being used today because they don't have lint issues. So that's the answer for that one. Anything else? Good questions. My third-party IAQ reports measures carbon monoxide and CO2 parts per million. You mentioned, yeah. So parts per billion is another way that chemical emissions is measured. Micrograms per cubic meter, parts per million, parts per billion. You'll see that listed sometimes both ways. Either way is fine. The conversion from micrograms to parts per million is this very long formula which you really are not interested in. So go with either one. Either one is acceptable. Getting an indoor air quality inspection for a site, things to be wary of or looking for? Well, make sure that first and foremost, when you're doing an indoor air quality testing of the facility, you use a fully competent indoor air quality testing company. Air sampling needs to be done in very specific ways. It needs to be done at specific times of day. It needs to be done in specific locations throughout the building in order for it to be truly credible. This is a very, very important aspect. And so using the right kind of equipment is key. Things that come over the web, you do-it-yourself test kits are not reliable and do not provide credible information. What else, what other questions you guys have? Somebody says, where can I find a checklist of things you brought up? Checklist, you'll be getting the presentation. I'm not sure I completely understand what you mean by checklist. The presentation will give you that information. You can also go to the greenguard.org website and find more information about how each of these things that we talked about in the design, construction, operations, and maintenance phases are impacted by chemicals. Oh, okay. That information really should be provided to you by the air quality testing company. As far as a checklist, I can refer you to a company who does that kind of testing. They don't work for us, but they are consultants who we have worked with. If you'd like to find your own, that's fine as well. But they will provide a legitimate specification list of how they're going to do the process.
And if anyone can think of any questions that they don't want to answer, they want to ask here, they can always email me and I can forward it to Paul, and I'm sure he will be happy to answer your questions.
Absolutely, and as I said, my email directly is paul.bates@ul.com, and that's B-A-T-E-S. Well, thank you for attending today. I appreciate it, and like I said, we'd be glad to help you any way we can. That concludes our presentation.
All right, thank you, everyone. I will be sending out the links so you can rewatch this webinar, and also I will send out the presentation. I hope everyone has a great afternoon.
Thank you, Mary.
Thank you, Paul.